Hi, my name's John, and I'm going to be talking to you on this video about the 16th character of the Greek alphabet, pi. Um, Pi is described in mathematics as the ratio of a circumference of a circle to its diameter, and I'm going to put that to the test. I'm not sure if that's actually the best description of how pi can actually be calculated accurately. I understand that Isaac Newton did a lot to improve the calculations of pi, and I've studied a lot of the work that he has done, both in gravity and with pi, and I became very fascinated with the differences between how we mathematically write time, how we understand proportion, how we look at ratios and approximations. And I put together this, I'm trying to keep it short, or at least as short as I can, video on actually ratios that can be created that are precise in a circle's circumference in proportion in a way to its diameter, but what I am introducing as a point of fact is that when we look at a circle, and I have a drawing up here right now, we look at the diameter from point to point going across a circle's circumference. What some people don't understand is the diameter is actually a chord. And if you don't know what a chord is a line segment that runs across a circumference from point 1 to point 2, point 1 on this side to point 2. In any case, it touches at both ends of the circumference. So the diameter is a little bit short, and that's the stigma or the issue with why pi becomes a calculation. And I will post these, or my list of circumferences that I calculated. We look at pi as the number 3.1419 most often. I replaced it with a number which is 1.5702, which is actually part of a ratio. It has some issues with scaling as far as accuracy goes, but I might get into that in another video if I get enough people interested in this video. I'm not sure how people will even take to understanding that, pi is an approximation. Just to go over a little bit of information here, YPI is a term that I'm using to replace just the understanding that pi is PI. There was also a drawing I had gone over earlier. CPI is also identical to the YPI, and there's two other expressions which would be XPI and ZPI. And if you understand basic, I guess, ideas of space and X, Y, and Z coordinates, you can gather what I was doing there mathematically. I'm again not going to jump into too much of that. The interesting point which gave me concern or raised my questioning of how to actually calculate a series of ratios that were not approximations and were proportional came from time, and understanding Einstein's theory of relativity, that when he was going over calculations about traveling at the speed of light, there were inconsistencies with returning and age of people because of time. And what conclusion I came to mathematically is that time is a form of proportion, and it's what would be considered a continued proportion. And if you look at these symbols down here, we have 12, 17, 33, 12, 30, 30. These can be seen as times, basically 12:30 and 3:30 seconds. Sorry about that. 12 hours, 17 minutes, and 33 seconds. This is important to understand because these three numbers are all precise to each other. They're proportions, and that's part of what made time very unique. And I think it caught the attention of Isaac Newton. I could even, in some ways, justify that Isaac Newton's arguments of me one moment, it'll come to me, laws of motion are actually based off of decimal points and how the series of mathematics creates irrational numbers in which the decimal points seem to move on forever or give certain objects the illusion that they can continue on forever, because pi itself, with over 1 million characters, is just getting smaller and smaller segments of motion. But every one of those motions is actually still going around the circle, but the claim is it's not, and that's just not mathematically feasible. So a precise proportion has a set series of decimal points, and that's all that will be. There are no more than that. So 5702 is the end of the decimal points, which was part of the series of creating a rational, precise ratio. And again, I think before I conclude this shorter video on the actual ratios of a circumference, because like I stated, I used a different method of calculation to come up with the circumferences. It is different, but not necessarily different, in that, again, we're still using a chord, but we're calling the chords what they are, chords. And the diameter of a circle was always a chord and was just not identified correctly as a chord. And maybe if it had been, there would be a better understanding to how the approximation came about and why people use it so popularly, which, you know, it's, I guess, if the approximation works, it's great, but in navigation and things like space and some computer issues, it's really not good enough, which was part of what also led me into looking into the mathematics behind this a little better. So we had a scalene triangle, which I had gone over, or I'm not sure if I'd gone over yet, which has the ratio of 3:1, 2:1, and 1:1, and these ratios occur outside the radius and outside the diameter or circumference of the circle. But what's interesting is you can calculate through geometry and create a scalene triangle that actually has one side of the triangle, which would be the red side here, which is the same length as what the circumference of a circle could be, which then means you can calculate using some known geometrical equations, tangents and whatnot, the actual length of the one side, provided that you can get either these angles or distances from what would be a diameter here and a length here. They're just food for thought, and again, I'd appreciate if you got some kind of gain out of this and it wasn't too confusing, because it often confuses the heck out of me. You like the video, and I will see about trying to add some to the collection, going over time, and even going into greater detail on how you can actually come up with the scalene triangle that is proportional, so that you can in fact come up with the one side that's the identical length of the circumference. Having said that, please like the video if you have enjoyed it. If you haven't enjoyed it, and I would hope you at least have found it amusing. I found some of this mathematics very amusing myself, and in debates online I've probably either embarrassed myself or upset some people in saying certain things, but the reality behind it is that there is a way to create a precise proportional ratio. And Einstein, with general relativity and that all things are relative, is not true. Relativity is not relative, and I had that argument with a math teacher of mine when I was a lot younger in high school, because the relativity is created by pi itself. So it's not generally relative, it's force relativity on everything else because of pi. Having said that, I am going to conclude this video, and again, please like.